Hello everyone, welcome to another episode of the series where I make a full Scala application from scratch. This is going to be a shorter episode, much shorter than the last one especially, which was over 2 hours. Um, I'm actually going to do something that I didn't schedule in the last episode. So if we look at the list of things that I had planned before, also I've moved my face to a different corner. Hopefully it's gonna be easier to show more code at the time this way. So I said we would do some compatibility testing for the client and server and add some useful logging to the server and some error handling to everything, essentially. But this is going to take a little more time than I have scheduled for today. I just wanted to record something, and I think we can do something else in the meantime. This should be under an hour, maybe even less. So for this episode, I think we will make the client a native application. What I mean by that, we're gonna build the client with native image. So native image, for those of you who don't know, let me fire up the browser. So native image is basically a tool in the GraalVM toolkit that allows you to compile a jar to a native application, something that doesn't require a JVM or the presence of Java at all, something that you can just build on a system or for a specific system and architecture and run it as an executable. One extra benefit of not having to run a JVM is that the startup of the application becomes insanely fast compared to a JVM application. When we run something with Bloop, for example, that's just because it's gonna have to compile. Sometimes in this case it didn't. So it's basically, you spend 1 second or maybe 2 seconds waiting for the JVM to just start because it's a virtual machine. And if we are able to compile that more into actual native code, then we should have virtually zero wait, like just milliseconds. So I think for the client, if we want to have a good experience like with the Docker client, if we want this in Steve, in the client for Steve, we will want something similar. So I think it's a good point to add this right now, while we don't have that many dependencies. It's going to be easier to build at this moment, and then later on we can adjust it when needed. We can add more configuration to build it when more dependencies are there. I'm mentioning dependencies because the characteristics of how native image works, sometimes there is reflection involved in your applications, even though you don't see it clearly. And the compiler of GraalVM of native image, which goes through the jars, cannot really figure out when or what to instantiate. So sometimes we need to help it a little. Thankfully, applications in Scala, especially purely functional Scala, don't use a lot of that. So we should have a mostly seamless experience with that. But sometimes it's just not that straightforward. So our goal is going to be to have like a runnable client and something that we can run with almost zero startup time. So this is what we're going to do today, and the rest we're going to do next time. So let's get to it. There are two major ways to, hold on, let me just verify if we have music. Yeah, it looks like we do. It's just not showing up in my OBS. There's two main ways to get GraalVM native image for Scala. Two most popular. One of them is using SBT native packager, which is an SBT plugin that allows you to build, for example, a runnable script, which does use a JVM. It allows you to build a Docker image and a couple more things, including a GraalVM native image. But for this one, I'm going to use something else from Scala Meta. It's called SBT Native Image, just like that. This is the second alternative option, and I think it's in some ways it has a nicer experience. I've used it before. I'm not by any means I'm not an expert in this area, and I kind of do things until they start to work without completely understanding what's going on. But this is how we learn. We just have to, sometimes follow whatever the instructions are and not ask questions until we are ready to understand the answer. So I know that we need to add the plugin to our SBT plugins. I'm gonna do that. And we're actually not gonna spend too much time in the IDE today. So I'm not gonna even import this to Metals. We're gonna mostly stay in SBT. So I'm going to have to reload a couple times, maybe even 100 times, who knows. We definitely need to enable the plugin. We're gonna only do it for the client, because the server, I don't care if it's going to have a long startup, it's going to be long-lived, so I don't need to start it instantly. For the client, we're gonna, like when we are actually using the client as a CLI tool, we want this to start pretty fast. And again, this application is not going to be used by anyone in real life like Docker would be, but still, I want to simulate that part of the experience if it doesn't require too much effort. If it's a lot of effort, we're not gonna do it. Maybe at some point we're just gonna disable this altogether, roll back to a version that doesn't have that, and call it a day. So we need to specify the main class. I assume it's because it just doesn't find the main class for you. Like in Bloop, when you want to run an application or in SBT, you don't have to specify a main class if there's just one. But I guess here we do have to specify that, which is not an issue at all. So for the client, we have steve.main. That's actually the same name as in the server, but it's not going to clash because it's a different module and they don't share a class path. Like not all of it. We just share the shared module on the class path and the dependencies, some of them. So this is steve.main. Nothing too difficult. And I guess we can try to build the native image already. So the command, according to the documentation, is the name of the project / native image. And I expect this to slow down the recording a lot. It's going to take a lot of time, so I might have to skip some of these parts. Hopefully not. A normal, typical time when I'm not recording for this to run would be up to a minute sometimes. So if we can make it within that time, I will be satisfied. I'm just going to try to keep you entertained in the meantime. Well, I guess it's going to take us some time before we are even able to run this. So I suspect this is going to fail. I already tried this in a similar application and there was always something that I had to configure. This is because we are already doing like network stuff. We are actually making HTTP calls. We might also have some reflections somewhere down our dependency stack. Thankfully, most of what we have, like HTTP4S and Tapir, it shouldn't require a lot of that stuff, but then, yeah, who knows. And also I noticed that we have a unit in the main class path, something I didn't realize before. We'll need to put it into the test configuration only. There's no point to have a unit on the main class path, because one, we're not going to use it in the main, in the application, just in the tests, and two, we're not going to use it. It's just a waste of space and polluting our class path. So I'm glad I noticed that. So we already had some issues. Incompatible class changer. Interesting. There's more. Okay, so I don't really understand what's going on here. Couldn't find the encoding method. But as I said, I'm going to outsource the understanding to someone else and just do things that seem to work for this purpose. Like if you understand native image better, all the things that it's doing, feel free to try to explain this. I'm just going to follow the general guidelines. Actually, let me check without, like if we, no, not clean, I wanted to reload, but that's fine. If we run this again, one thing that I already know we can do is run the application normally without native image and let it sort of, like it's going to attach an agent to the application and it's going to collect some information about what it needs that it couldn't resolve from just compiled jars or the compiled classes. It's going to look at, for example, what is used from the reflection part or what resources are being used and so on. And then we can reuse the files that this will generate to build the native image in the end. Currently, we are not doing that. We are just trying to build it. I don't think it's gonna succeed, but we'll see. There's also some more options that we can define that should help us in the longer run. I'm looking for them here. This is what we're gonna do later. We're gonna specify like the reflection configuration files. And I'm also looking for some more verbosity on this. I'm actually going to steal this from another project, Complete Goal. And it's an open source project that I started a while ago, and we are, well, me and some ex-colleagues are working on it. Sometimes it's still being used. And it does contain a native image build. Also, I mentioned I actually worked on this project for a video on the Cast Effect 3 migration. So you may recognize the name from that. So there's a bunch of setup here, but what I'm looking for is the Bootstrap project. This is the thing that's compiled with native image. Okay, this is what I wanted. So I wanted these two lines. I'm just going to blatantly steal them. And also we should specify the native image version, especially because I think the one being used is not the one that I wanted to use. It's not the same as my installation of GraalVM. It probably doesn't matter, but I just want to keep a consistent version. Transient error. So I guess we can potentially ignore that later. But yeah, I think the error that we got right now is the same as this before. So there was this native image options. And it's a seek. So I'm going to add, oh, not that, these two. So the first one here is going to show us some more detail when we fail the build, when something is wrong for native image. And the second one is going to be just, if you fail to build everything ahead of time, like normally GraalVM native image would would fall back to an image that actually requires a JVM. So I don't want that. I don't want this fallback, so we're just gonna add that. And from here, I think we're fine. I'll just set the version, but this is not the one that I want to use. I can check that with like I don't even know yeah, it's component updater. GraalVM updater, I guess that's the shorter version for it. So I have 21.2.0, and that's probably the same as my Java version, GraalVM 21.2.0. So I'm gonna use that for the native image version. Actually, I think this is a major difference between SBT native image and SBT native packager. A packager would require you to install the native image binary yourself, but SBT native image will actually fetch it for you if you don't have it, or I think maybe even always. And you can opt out of this behavior, but by default it will handle that for you. So it should be effectively less setup when we maybe want to build it in CI or something like that. Okay, I think my mic is sometimes a little too loud. It appears like in OBS it says like it's on the red part of the bar, but hopefully it's not too loud. I always think that my videos are actually too silent, at least my voice in them, but I don't really know. You tell me. So I'm gonna reload, and I'm going to do this other thing. I'm gonna run the client with the agent to collect these files. That will, result in a better setup for it. So we need the server to successfully connect to it. So I'm going to, I think it's native image run. Yeah, run or run agent. Who knows? Let's see with run. Okay, so run agent is the one. This will still run a JVM, a fork JVM, but it's going to attach this agent. Yeah. So now this succeeded, this is just the same as if I just run loop run client, the same result and the same behavior actually. I'm also worried about this because we have SLF4J in the class path, but we don't have an implementation. We did add logback to the server, but not to the client, so maybe we should add it just to silence this warning, because it could have some weird consequences if we don't attach an implementation. And I don't really want to find out what the consequences would be. So I'm gonna run it with the agent again. Later on, I guess we can try that again without logback, but I just want to save some time and add it right now. Okay, so now there's no log. We did have logback with no config. I guess that's why, yeah, there's no config whatsoever. I guess that's why this didn't log anything to standard output. So this should result in some files being generated in my target directories. I guess we should be able to look at them here. So client target native image configs, and here they are. So I think we don't really need this one. That's pretty generic stuff, and I was able to build some native images without JNI configs. Then we have predefined classes, which is empty. Proxy config, which is also empty, even more empty. I'm just going to skip these two for now. And serialization config is also empty. So then we have reflect config, which has a lot of stuff. I think we might need that one. And resource config, which does mention the static logger binder. So I guess this is required to initialize this class, like static logger binder, so that it finds the right implementation for SLF4J, which is logback in this case. I'm not going to think about this too hard, just going to copy these files and attach them to the build to see if that helps. And then we can try to see which ones we don't need or stuff like that. So I'm going to copy these two files to the resource directory here in main. So resource config and reflect config are going there. That didn't work. Okay, let me try that again. Yeah, I had a selection that included some other file. I don't even know which one. Just going to close everything and go back to build SPT. All right, so I don't remember the exact config. Yeah, I could steal it from here, but it's also mentioned in here. When we look at the run agent option, there it is. So we can add that. I'm going to explain what it does. So we're saying like we're adding a flag to the native image binary, the one that compiles stuff, that we have the reflection configuration, which is this. Like this is just saying where it is in the target directory. Oh, it's from target. Do we actually want that or? Oh, cool. We don't actually need to, or do we? I need to think. The question is whether this is going to work if we like commit this file, because these files that we use from target are probably not going to be generated if we don't run the application and like with the agent. So here it's suggested to pass the configs from target, but I don't think we're gonna have them. And in the other project, there's probably a reason why it's using resource directory. So I'm going to do the same thing as here, use the resource directory instead. Yeah. So compile slash resource directory instead of this, the native image configs. Or actually just reflect config. We don't need this directory. Yeah, I'm pretty sure I have to do this. Like this instruction in here only mentions target. Um, I think just, so that after we run with the agent, then we can build the image. Okay. We can also customize the agent so that it always outputs stuff into this. And then there's this flag to allow merging the configs. If we turn it on, which it's not, by default it's off. If we turn it on, then if I later run the agent again, it will potentially add some more stuff if we need to add more stuff to these config files. But for now, I'm just going to get to one successful build and call it a day. Yeah, let's see. So we specified the reflect config. Let's actually try to build it now. So I'm going to reload and try to build the image again. So the second file, the resource config, is not going to be used. I wonder what we're going to get. And also, I think, yeah, there's one more thing that I'll have to add, but probably we can do that later. So native image. And now we wait. So we can actually take a look at this file. So that's quite a lot of stuff. Let me just wrap this one. So some things that we see here, a byte array, that's kind of suspicious. We see some stuff from cause effect, from cause effect unsafe. I don't really know why we need these things listed, because they should not be, accessed by reflection. They should just be accessed by code. Same with fs2 chunk. So yeah, maybe it just generates a lot of stuff just in case. I don't really know. Or maybe there's something outside of the, outside of cause effect and fs2 that's calling stuff that does involve calling these things. Maybe that's the deal. But I wouldn't expect, all of this to be required when you just want to build a cause application or a cause effect application. Then we have Magnolia, which is part of the top tier dependencies. Some HTTP stuff, some MIME-DB. I guess this will contain like different MIME types, so content types basically, for the headers, the HTTP headers. Yeah, this is another like object in MIME-DB for the audio content types, fonts, images. The names are a little weird, but I guess that's how it works. Also, some of this might be caused by how lazy vals are encoded in Scala 3, or in Scala in general, because I know there are some lazy vals involved in some of that code. So maybe it is just caused by that. Maybe lazy vals do involve reflection. Steve.build, that's strange. We don't. Oh, we might have some lazy vals in here. In the model, do we have givens here? Okay, I guess in derives will generate some givens, and these probably involve lazy vals as well. Let's see how the build is going. Okay, it's still happening, and it's 2 minutes in, so that does take a little longer than I thought it would, or than it would if I wasn't recording. So we can just continue looking at these. We have some misc unsafe, which I guess every sufficiently advanced library will use. Hopefully not. I wouldn't be surprised if we could remove like half of all this stuff and it would still work. But who am I to judge that? It's I am not that experienced in compiling Java applications or JVM applications to native code. So it failed again. It discovered some unresolved types. I've already seen this before. Yeah, there's some stack traces, which is strange because this is compile time, but it's parsing this kind of code. Discovered unresolved type. Strange. Uh, I don't understand this error exactly. I could look it up, but I guess there's no time. So we are not using this type. We don't have any streams in our responses for now. So I would be inclined to just ignore these errors and use this flag that they specify here, allow incomplete class path. If we are able to use that flag and the application still works, I think it's going to be fine. At some point, it could just crash at runtime, and then we'll just add it. I'm thinking of ways to like test the native image after it's built, like doing some end-to-end tests to make sure that this doesn't happen, right? Like when we distribute our application, that everything is actually compiled and will not just throw at runtime. So after the reload, we should be able to build the image again. I guess it will also take 3 minutes or more. Last time it took almost 3 minutes. But yeah. Now I guess we can look at the other config that we have, the resource config. But this is, just includes pattern. There's not much I can say about this. I guess all of this is documented, like what happens in these configs. It must be. But these, bitmaps and so on, the names don't look as if a human wrote them. So I wouldn't be surprised if this is something just generated by the Scala compiler, probably with lazy files. Really difficult to say. But things like tuple2, or either, I wouldn't expect them to show up here. And yet here they are. So yeah, I'm just going to cross my fingers and hope that this works at some point. If this doesn't build, I'm going to try one last thing and actually include this file because it's currently not included. This would be resource configuration files, probably. I can look it up. Yeah, it looks like that's how you do it. One thing that could happen right now, if I don't include it, is the application could build, but it will not start. So just in the worst case, I'm going to configure it. It will not be used for the for the native image that's currently being compiled, but it might be used for, like, it will be used next time I reload the SBT build and try to build it again. By the way, I really didn't expect so many people would be watching this. So to everyone who's still watching after 2.5 episodes, I appreciate you very much. So it really helps that I'm not doing this for just myself, because the whole point is to show you how to do things. And in this episode, it's mostly me trying to do things without really understanding them. But hopefully it helps you if you have similar issues, if you're trying to do something similar, like a native image. And also, if you're trying to implement stuff as we go on as well on your own, feel free to post a link in the comments. I would like if you want to do things a little differently and like ask for opinions on whether your version is better or worse or whatever. If you want to just compare and share your solution, feel free to do it. I'll surely look at it. And always let me know what you think about the given video, about the whole ideas. If you have more ideas that I could apply to this project, if there's something I should explain in particular, like I know I will explain a little of the design principles that we're gonna follow. For example, the whole executor thing as a tagless final algebra. I guess some people might not be familiar with that. I'm going to go back to this probably in the next video and talk a little about that. I was asked in the first video, that was after I recorded the second one, but before I published it, I was asked about why I chose Toggle Final instead of, like, Cuts Effect and Toggle Final instead of Zio. There's a lengthy answer for me in there, but I did mention it might be, more difficult to understand Toggle Final in some ways, but I'm willing to help you understand. So I'm going to spend some time explaining the basic idea. Hopefully, it won't take too much time, but I guess just enough so that everyone can follow. Maybe without like a full in-depth understanding, but at least hopefully having an idea of what's going on. Well, I hope everyone already has that, like an idea of what's going on. Maybe not the deepest understanding, but we can always go deeper. I do have a video about Douglas Final, but it's quite outdated, and the way I would explain it right now has changed a little. But I guess it's worth watching anyway.
Native image ready.
Yeah, you probably heard that as well. It's a built-in thing, like it tells you when it's ready because it's such a lengthy job. Sorry for the jump scare. We can try to run it. So it's going to be in in client target, native image client. I have completions from a different project. So let's try to run it. Oh, it worked. Okay, so it just works. If you don't believe that this is so fast, it's a sub-second time to run it, and it does make the calls to the server here, as we can see. So it seems like it works. And what it does is just what I have in my main class. So just call the build endpoint and the run endpoint, just like we left off from in the second episode. Okay, so this seems to work, but I wonder if we would need this resource config if we wanted to, let's say, do some logging actually, because we currently don't. We don't have a logback file like the config, so I guess I would need to add that. Yeah, I guess we can do that. So for now, I'm just going to disable this for now. For now. And we're going to try to get a logback file, like a default one. I don't think anybody on the whole planet remembers how to set up logback without any documentation. So I want like an example config file for it. Great, this doesn't even work. Okay, I'm just gonna. Okay, this looks about right. Let's steal that. So in the resources, we'll need logback XML and configuration. So this is going to be like the format for the output in stdout. It's going to be a date. It's going to be the thread, I guess. Then the log level, the name of the logger, and the message, and then an empty line. So this will not include, for example, the stack trace, but that's fine. We don't need this really, do we? Let's just do root level info. And for Steve, the Steve package, we'll do debug. I don't know what this does. I'm just going to remove it. And I don't think we need to specify the appender twice. I'm just going to do this. Root level info. Yeah, I think that should work. So I'm going to add a log to the main class. Also, I will regenerate Bloop so that the Bloop application also has logback, because I think currently it doesn't. Last time we ran Bloop with the client. Yeah, it still didn't have logback, so now it will. Also, I didn't have to do like a full build import. I could do just Bloop install. I think what Metals does when you import, it will just run this, but first enable the semantic DB plugin. But we could enable semantic DB like in here by default. And then we could just run blip install from here to save some time. But I guess we have time. All right, so this is being imported. I will start to add a log. I'm just going to do it here in the main class. This might actually change how native image is being built, by the way. So I hope it will actually change something so we understand when we need this resource config. So I'm going to do info building base image. Then I'm going to print the result of building. And I guess we can also do like run image with result. And we will ignore the print line. And actually this can be flat map. I think this should compile. And the build import was completed. So we should be able to just run it and see these logs in here. So it found our config and it did print some stuff. I hate this, by the way, like it's not aligned the log levels because the threads come first. But you know, at some point you will have misalignment. I guess we can move the thread after the class name. That might help. I'm going to do this just because I'm a psycho this way. And it should automatically work. But we know that the logging works. So I wonder if we can get like all of this in the native image. That would be interesting to see if we get that. It's still a little annoying because of the misaligned hyphens, but I guess we just have to live with that. So we built the image, that's fine. And yeah, let's build the native image. So again, this is going to take probably 4 minutes. Maybe I'll skip it, maybe I'll find something interesting to talk about. So client native image. Yeah, I don't really know if it's going to work this time, but we'll find out. I can actually stop the server to save some resources. And yeah, we'll see what happens. So I'm not really a fan of SLF4J and logback for several reasons. One of them is that it does use reflection because right here when you initialize the SLF4J classes, there is some block, like static block somewhere in there, which will find any implementations for SLF4J that you have on your class path, and it will bind that specific implementation probably forever or until you change it. And well, what's wrong about that is that it's kind of implicit, it's hidden, and it's runtime. So I would much rather have like a global singleton that you have to call with, you know, I want to use logback or I want to use this. It's kind of, you know, looking at the class path to see what you have at runtime to choose an implementation. It doesn't really speak to me. Like not even a singleton. I would be fine if I had to, you know, just specify here I want to use the logback backend, like with, you know, HTTP clients in HTTP4S. But then again, this would require you to pass this implementation to every library that uses SLF4J, which might not be such a bad thing, because now if you don't have to pass it, if libraries can just do this and rely on your class path, then you know everyone can log what they want and it's kind of a mess. Yeah, I guess I'm just a fan of passing arguments to functions. That's what I'm trying to say. And SLF4J doesn't work that way. And also there's like some extra mess if you want to do like logging context with MDC. Try to combine this with effects like functional effects or any kind of async code. You would have to either do, instrumentation with common or whatever, like with, aspect-oriented programming, whatever. Or you would have to pass the context everywhere manually. The problem is that libraries like Akka or whatever, like libraries that use MDC or SLF4J, libraries that use SLF4J will not allow you to pass the context to every logging method because it would be just, polluting every possible method signature with the context that you want to pass, and that would just not scale. In the functional world, we have something called reader monads for this, or Zio has a context thing for this kind of purpose. Not only for that, but does have it for that. In Cas Effect, now we have fiber locals, which could be used for that, or IO locals. Same thing, basically. But still, the Java code in SL4J is not aware of that. So there's no way that everything could just work with it. And also, if you were able to get like the current context in an IO, you still need to run that IO in order to actually get that value out of it. So without like an IO runtime in CatEffect3, or without a runtime in other effect systems, you would just not be able to do that. So it cannot be a thing in a Java library. Maybe someone had like, if we had like an adapter for SLF4J which was aware of that, I guess it would be doable. It probably is, because that's what you do when you want to integrate with different logging libraries like Odin, which is a pretty neat logging library. I would have just used that, like if I could, but sadly, I think HTTP4S is hardwired. At least the Ember backend is hardwired to use SL4J. So the only choice that we have is the implementation for
Native image ready.
Shit. I forgot about this noise. You're just gonna be awakened every time this happens. Or I can try to turn the sound off in here. Okay. Does nothing by default. Oh, so it only says things on Mac. Well, it doesn't make me happy. Like any happier to know that this only happens on Mac. I'm just going to set it as an empty task. Is it unit to unit? Yeah. I'm just going to ignore this sound. So apparently it worked. Let's see. In the meantime, I'll just reload so we don't get the annoying noise next time. Also, I may like lower the volume for these loud parts in editing. So the client failed because we don't have a server, I guess. Also, the stack traces are ridiculous here when we don't have a JVM. Like normally you would have only half of that, but here there's some more stuff. Like this, that's not a JVM signature. Anyway, let's run it again. It worked. And we only got like the actual logs that we wanted, which is pretty nice. We didn't get the boring stuff that gets printed here, the intro here. I think you can also disable that in SLF4J or in logback. I'm not like super sure, but I think I had a discussion about this on like Twitter. Interesting that it doesn't show up in here. I guess it might be done at build time. Yeah, interesting. So this works without resource config. So I think we can just remove that and call it a day. So yeah, we added this allow incomplete class path, and even though we did that, this seems to work. and we are getting, normal behavior in the successful case. When there's like an uncaught exception, it does fail, but I guess we could just as easily catch it. I could actually try because it's not a fatal exception, so I'm going to try it. Interesting, there's a retry middleware. There's a retry middleware in Ember Client Builder, which I didn't add, I think. There is a built-in retry policy, which I didn't know about. What is the middleware? Here it is. So Ember always wraps it. I wonder if you can do it without the retries. Probably not, because build does that. It just yeah, it just wraps the client in a retry. I guess we would use like a retry policy that says don't retry if we didn't want this. That should be pretty efficient. But we don't need to care about that. So what I'm going to do is just catch. Yeah, I'm going to just attempt here. Or wait, I'm going to do the cover. How's that not a thing? What? Huh? Huh? Okay, let's just make sure Metals is understands what's going on. I'm just going to wait for success, and there it is. Yeah, I'm going to do. Actually, I can do handle error with, and then we're going to log it, something like that. Almost. Log error. I think the exception goes first. And this might even be of the right type. Let's run it with blue. So this is how we would use this, in development. You would not build a native image every time, by all means. Yeah, you would not do it. Strange, it didn't. Oh, wait. So I don't think it worked. Let's try it again. Yeah, I wouldn't expect to see so much stuff. Wait, I guess, okay, unhandled error shows up. And there's the exception. Strange, because I didn't think we would see the exception here. So I guess message would contain that, or it just gets added automatically. I'm not sure, and I'm not sure if I want to know. But we do see like the stack trace for the exception. I assume this is because we put it into the error message, like the error log. But I'm not sure why we see this. Okay, this is printed by the retry middleware. So maybe I can specify it to not retry. Essentially what I want to do is like catch everything. So I will skip this exception for now. The whole point of this is, actually I can do or else, I think. The whole point, I might have to import cat syntax for this. Yeah. The whole point is to hide the exceptions right now. Like I'm not going to keep it forever. I just want to do it for the purpose of the demonstration. So default with retry policy, I guess. And let's see. I don't remember where the policies are. Maybe in the retry object. Probably not. Okay, how about retry policies? Is there such a thing? I don't think there is. There's retry policy. Okay, there's a companion object. So default retriable, request to retriable. Could I do like don't retry? Or do I need to do it myself? So we need a backoff, which will return like an option find iteration. None to stop retrying, so I guess just returning none here will be fine. And retriable, returning false. Yeah, let's do both, just to prove this. So what was retry policy again? Is it just like a case class, or oh, it's just a function. Oh, it's even easier than I thought. So we can just say we take two parameters, three of them actually, and return none. So I'm gonna do exactly that. None. That should probably make sure we don't retry. We will definitely not retry, but the question is whether it's going to print stuff. Yeah, through an exception on attempt one giving up. So this might be, we might see the same thing. I'm like 50% sure this will be what we see, which is fine. We can also silence the whole logger here. So this is, yeah, I'm going to do that. That's info. I'm going to change it to error, which would not show info logs. So we'll ignore the retry policy and the whole retry thing. I'm going to hide it. And in the logs, we'll do this, lever error. I don't even know if this needs to be uppercase. Probably not, but I'm going to do it just for good measure. And just to make sure, get the config is fine here. I don't think I even need to reload. So I'll just run it here to verify if it works fine. We should see just, okay, that looks fine. And if there is a server, I don't expect this to, behave any differently than before. We can start building the image in the meantime. So yeah, if the server is there, it works just fine. So here's to another 3 or 4 minutes building. Yeah, that was like 5 minutes, yeah. So what do we talk about? I guess we can talk about the next episode. So, oh no, what did I do? Okay, hopefully nothing. Um, so yeah, so this is our third episode. It's going to be, I guess, an hour long or so. So episode 4 will be, this time I promise I will do this. So the client-server compatibility testing, that's going to be pretty interesting. I mentioned this at the end of the second episode. We will create a client that connects to a server from the HTTP routes value or from an HTTP app, uh, which we'll get from Tapir. So this should make sure that any errors such as what we saw last time in the previous video, like the whole, I think, half an hour of fixing Tapir issues, and then another one for a different issue, which is also, uh, caused by the Tapir decoding. Well, these tests should verify that we don't run into cases like that. So we'll create a client from the routes. We'll wrap that into the executor, um, and we'll do stuff. Probably generate like random builds and random hashes and see, like with Scala check, do some property-based testing and see that whatever we build with the client is the same value as with the server. And this is probably going to fail in the presence of errors. Like this will not be the same behavior because of different, uh, when you have an internal server error. I don't think we handled that very well with Tapir so far. So we will need to change that, add some sort of generic error handler that will return a generic parsable response, probably just a 500 with no details whatsoever. And then, yeah, I guess we'll still need to change the test so that they don't compare the errors like exactly for equality, because they will be different. Like if it's a throwable, it's never gonna be the same across machines. We will not serialize throwables that way. But I guess if we treat them as like case classes, maybe. Yeah, we're gonna see. So we're gonna work on that. This is probably gonna be enough time spent so that it's a whole episode. But if not, I guess we will always find something more to work on. Also, I mentioned we were going to do HTTP for now, but later we would move to a Unix socket. I saw there's an issue open for that in HTTP4S to have the Ember backends, like the Ember client and server, be able to talk over a Unix socket. So hopefully by the time we want to implement that, this will be ready, so we'll be able to do HTTP over a Unix socket, just like Docker does. That would be pretty nice. Or we can go the other way around, so we can switch to a binary protocol while we are on HTTP, or on TCP actually. And then from TCP, we would switch to a Unix socket. Yeah, I guess we can go both ways. And it will probably depend on the exact timing. Yeah, this should be ending pretty soon. Mm, I wonder when this Scala version will be released, like 3.10. Uh, I'm not sure what the timeline was, but there's supposed to be, I think, a minor release or a patch release every 6 weeks. And I wouldn't expect if the timeline for like minor releases, like 3.1, 3.2, is 6 months, but I don't know if that's the case. I guess we'll see. But the timeline for some releases was at least published previously. Okay, so we have build artifacts. I wonder what that contains. Nope, I don't want that. Yeah, that's just the executable. Fine. Yeah, let's run it again. This should print. Oh, okay. Oh, interesting. Okay. Actually, you know what? I don't think this is using our config at all. Or is it? Or the config hasn't changed. Wait a minute. We changed this to error. This is an info message from retry, and it still shows up. So here's what I'm gonna do. I'm gonna run the agent again. There we go. And I will I will look at the resource files generated by this. There we go. This will be in the target. Resource config. Okay, this is different. So, okay, now this definitely looks like I will need to include it, at least for the logback XML file. And the static logger binder, I'm not exactly sure if we need to include it, but if they are saying it was used, then I guess there's a reason. I wonder if this changed much, so I'm going to try to diff these files after I format them. The other one was formatted already. Okay. So let's do just a diff. This is client target native image configs, resource. No, wait, reflect config. And then client source main resources, reflect config. Something changed, but this is JSON, so it's difficult to look at it. I am going to use JSON diff. I do recommend comparing JSON with something that's aware of JSON structure, not treating that all as strings. So here's the config that we had before, and here's the new one. Actually, hold on, I probably have a message. Okay, we have time. That's good. So let's get the diff. Okay, this is confusing. I wonder if we can do like ignore order in an array, because that probably doesn't matter. Yeah, I don't see any options in here. Are there? Because I'm pretty sure this is just a matter of like different order. Okay, there's a semaphore in here. Is the semaphore on the right side? It's not. Okay. That was the previous version, right? The semaphore is in the existing. Oh, because we run the failure case right now. That's interesting. We'll need. Yeah, I think I'll do this merge thing. Yeah, the new one is longer. I'll run it in the failing case and then the success case, and we're gonna merge that. So we do have the failed case. I'm going to set this setting to true. Run it again, like the agent after a reload, and I'm going to just relentlessly take the files, both of them, to our output, to our configs. So first we run without a server. This should fail. And it did. And now we start the server and do it again. I'm going to look at the files and see if they change. So client, target. How do we do it? Can you do like a SHA-SUM? Yeah. Like a SHA 256. And let's run it again. Actually, I should have checked the length. Okay. I hope I did it in time. It's longer, so you know. How about I clean it? I run it again in the success case, and we'll see what size it is now. If it's 486, then I'm not gonna be super satisfied. But I guess we'll see. This is probably not a reliable way to see what's happening. Like we could merge the two lists ourselves, but whatever. Oh, that's interesting. Okay, it couldn't find the file for merging. So I think the merging should be working. Like it already complained that there is no file to merge, and we probably need to go to the directory again because it's a new one. Yeah. Okay, 483. That was with the server existing. Let's run it again without the server. And actually I'm gonna, oh, I didn't run the SHA-SUM after the second run. So it's gonna be useless, but it's probably fine. So 486, isn't that what we saw before? It is. Okay, this is slightly reassuring. Not completely reassuring, but still gives me a little more confidence. So let's take that file, replace, and we're gonna take the resource config as well. And it only includes these two things. We need to enable it again here. We already had that, but we removed it. So resource, configuration files, resource config. And I think that's fine. We can reload in SBT and make a native image. So this is going to be the last thing we do. I'm just going to add some like to-dos to remove the, like to fix the logging situation later. So this, because we're not gonna, this is kind of a useless message. It doesn't have any context and so on. Also, I think we might have to set up. Yeah, I'm not sure what we're gonna do, like whether we're gonna stick with SLF4J and log for cats, or if we're gonna use Odin for logging at some point. In this other project in Pitgal, I do have Odin and SLF4J, and Odin is being used as an implementation for logback. Let me show you how it looks. There's actually a Java file for this because we need like a static member. But it was in Scala 3, so I guess we can do actual statics in Scala 3. We might try to rewrite this in Scala 3. Anyway, this is basically the code that you need to copy paste. And then there's this Odin interrupt, which is also what I will probably copy paste. Yeah, this is just to, bind the reflection based world of SLF4J with the more compile time functional logger from Odin. Yeah, but normally you would use Odin. Like, it's actually a pretty nice thing. I think we define it here, logger. Yeah, this is how we make it here. So we configure everything in code, like it's a rolling file logger. It's also async, so that when you log, it's instantaneous for your control flow, but it runs sort of in the background to append to the file. It will create a file based on this pattern and pass, like you get the date, it gets injected into it, so then you kind of can use the date for the name. We have how long it takes to roll over a different file, what is the max size of a file, which I guess we should be using. Like, I don't even know what happens when you reach the max size. Like, do we get a new file? Like, how is it going to generate a name for that file? Is it just going to overwrite that or just remove the initial logs? I guess I should look at that. But this wasn't a serious application anyway, so, and we don't have this many logs, I think. There's a buffer size for how many messages you want to keep in the buffer. Like, when, I assume when this gets overflowed, when this overflows, then the logging action would actually be semantically blocking. So you would actually have to wait for that. In a non-blocking at the call side fashion, but somewhere there is probably blocking involved. For example, when writing to the file. Yeah. Then we have a formatter. So this specifies how to print this to cd out or to the file. And I have no idea why we do colors in the file. That's interesting. We do a console. Okay, wait. Yeah, okay. I thought the formatter was part of, like, a common thing, but we specify separately for the file and the console output. Anyway, we combine the two loggers with a semigroup, which is quite interesting. It's actually a semigroup of resources, but underneath it will combine the loggers with a semigroup as well. And then when it's built, this is basically just a hack to get this Java interrupt to work. So after it gets initialized in the functional control flow as a resource, we will put it into the imperative Java global reflection-based runtime control flow. So that code like HTTP4S logs, which use SLF4J, we actually use this logger underneath. Maybe they will not see like all the logging context that should be visible at that point, but at least we'll have a consistent output for things. You'll see everything in whatever Odin logs do, including the logs from HTTP4S. And everything else, like we can just pass the logger, like the single instance of a logger, which we built in that resource, like here. We pass that everywhere, and the logger name will be generated at compile time using like a macro to show you where you actually called the logger and not when you initialize that logger. So I think this would be cool to have here, but it's probably not that important. I think we can stick to SL4J. I guess we'll see how much stuff we want to put into the logging context and so on. If it's not too much trouble, we'll just pass the context manually. We'll see. So this supposedly built. This is the real question, what happens when I run this? So first of all, we got the prefix here, which I guess explains why we didn't see it before when running the native image, the compiled native image. So we didn't see it before because the config that we had was ignored. And we also, I guess we also needed this line. It would take me too much time right now to check it, what would happen if this was missing. So I'm not gonna try it again. But I guess if I removed this, there might be some different way to log, probably without this. Anyway, the combination of these two makes sure that we have the same output as in the JVM based application. And it's actually running pretty fast. That's still amazing. Like even the instantiation of all of this is all happening in 15 milliseconds. That's still decent time. So we have info error, everything was fine. We ignored the output from the client. And when we do have a server, which has a surprisingly long startup time right now, right, compared to the client. And yeah, it still works. So I think we're fine. Okay, so we have these 3 new files in the resources. Not much else. Just some code in here, better logging, just a to-do for later. We will take care of it in the next video probably. Then we have the plugin that we added in here in SBT. Some configs for the native stuff. I guess we can separate it out into a list. So like something like that. Actually, I don't know why I keep using sig here. It's like a convention that somebody started, but there's no real reason to do it. These lists are so small that even using like lists would be fine. Like, you know, it doesn't really matter how you are going to traverse that, as long as it's a sequential sequence that you can traverse many times, it shouldn't really matter. I guess it's shorter than this. That might be the reason. But I think the default implementation of sig apply is still going to be a list, probably. An empty list is definitely a nil. Yeah, I want to see that. Hold on. We're gonna check in the Scala REPL. If I do a seq 1, 2, 3, 4, what is that? That's a list. How about... Okay, that's still a list. Actually, can I do it like 1 to 20? Oops, not that long. I can probably do it this way. And it's still a list. So yeah, there's really no difference. It's just syntax. Yeah. And of course, because this returns a seq. Okay, that's wow. I'll need to change this type. What is the type here now? Setting. Can I just do like setting, a list of setting underscore? I really don't like it when type inference gives you things like that. It's not even like a union type because this is Scala 2 still. I wanna see if there are implicit conversions in here. Rough settings definition. What does it convert to? That's not what I wanted to see. Yeah, I really wish you could go to definition of an implicit, like an extension function. Well, this is an implicit conversion. So if you could just click it to go, but when you click, you'll go to definition of the thing that's being extended. So hopefully this can be changed in the future of metals. Right now it doesn't work, we need to go there by hand. Wrap settings definition, is that the one? It is. So this is a settings definition. I guess, yeah, seek setting underscore, that's what is being wrapped. I'll stick to this. Or we could use this type anyway. I just don't want whatever this was. Yeah, I don't want to see this. So let's do it like that. Just gonna reload to make sure it still works for SBT. It should. Did we actually use it? We didn't use it. So, native image settings. Ooh, wow, this is strange. Required list SBT setting. Why? Oh, because I said list. Yeah, I wanted sig. See, I talked about lists too much, so. Okay, it works. I'm not gonna even try to build this again. I trust myself enough. Foolish me. One last thing, we reused the logback version. I mean, we should reuse it. So, by the way, I think there's a newer version, like 1.4. So this is going to be versions logback. And I'll just make sure this is really the case. I'll just run the update task. and maybe bloop install. So yeah, I think the dependency was there, like the newer version. I don't see it here, but it's probably there. Anyway, it seems to work the same way as previously. So yeah, let's do a final review of all we did today. So we have 3 new config files, some changes in main, some changes in the build, of course, also the README, yeah. So we did build a client with native image, add logback to the client temporarily, silence client errors. And we defined the plugin. So yeah, the point is that you need to check this in, otherwise you would have to regenerate it every time you want to build the client. Well, every time you do it after pulling some changes. One thing I wanted to remove the spaces. We're gonna just format this actually. Yeah, like trailing spaces in this in files, like spaces after line endings. I'm not a fan. Okay, it looks good. Oh, also I forgot to make tags for episode 2 and for now. I'll do it in the meantime, just not to bother you. Or actually, if you want to watch that, I'll do it. Yeah, so episode 3. So the point was, episode 2 was done somewhere here. Like either of these two can be named that. So episode 1 was here. This was added after the episode. Yeah, I guess I can do it here, like on the previous commit. Yeah, I think that works. What is that? Okay, I had this tag, I guess, to have a reasonable version whenever we actually build the application. Anyway, we'll go back to main. Okay, and episode 3. That's just this one commit. That's fun. And yeah, we'll push the tags, we'll push. And yeah, so thank you for watching again. And I think I'll see you next week. That's all I have. So yeah, leave a comment if you like this. And yeah, I hope you have a nice day. Bye.